Hi everybody, welcome to another math tutorial. Today we're going to be discussing how to solve equations using multiplication or division. We're still in one-step equations. Eventually we're going to get to two-step and even inequalities, but today your learning target is I can describe how to solve a one-step equation using multiplication and division. All right. Our key idea is very similar to what it was with addition and subtraction. If you think back to that, it says if A equals B. Okay, so let's say we have 7 for A, and that equals B, so 7 equals 7. It says if you multiply each side of an equation by the same number, it produces an equivalent one. So if I multiply A and B here by C. Okay, let's say C is 2. So if I multiply this side, multiply A by 2, and I multiply B by 2, I should get the same thing. And yep, 14 equals 14. It's that whole idea that we had talked about before of an equation being like a teeter-totter or a balance beam, that whatever you do to one side, if you multiply by 2 on this side, you have to multiply by 2 on this side so that your teeter-totter stays the same. It doesn't tip at all, okay? And the same exact thing goes for division. So if, again, we had 7 equals 7, and I were to divide each of these by 1, okay, if C is 1, I would get the same thing because I divided by 7 on both sides. I'd get 7 equals 7 again. Notice the only stipulation here is C cannot equal 0. Because you cannot divide by 0. If I were to take 7 divided by 0, I'd get in my calculator error. We can't divide by 0. There's nothing to divide by. We can't. Okay. So very similar to the key idea from last section, that whatever you do to one side of a scale, you have to do to the other to balance it out. All right. So let's see what that looks like in a few examples here. It says for letter A, solve x divided by 3 is equal to negative 6. So what number, when we divide by 3, will give us negative 6? Okay, I'm still going to ask myself that important question that you're probably getting sick of hearing from me, but it's so crucial that you ask yourself this question. What is being done to my variable, and how do I undo it? Okay, so that's what I'm going to ask myself here. What is being done to my variable? Well, x is being divided by 3. So to undo that, I would need to, what's the inverse of dividing by 3? Well, that would be multiplying by 3. So let me write this out here. X divided by 3 equals negative 6. Again, to undo this dividing by 3, I would multiply by 3. Whatever I do to one side, remember this dot means multiply, I need to do it to the other side. Now, you might be saying, well, what happens here? What is 3 times x divided by 3? Well, remember that when I multiply by a fraction, I can just put 1 as my denominator here, right? 3 is the same as 3 over 1 times x over 3. What would I get? Well, 3 times x is 3x over 1 times 3 is 3. What is 3 divided by 3? Well, that's 1, right? So I'd be left with 1x. And that's what I want. I'm trying to solve for my variable. How many of 1 do I have per x? So 3 times x over 3 is, well, that just cancels out and I'm left with x. Again, same reasoning here. Multiplying by 3 and dividing by 3 are opposites. They undo each other. Equals, now all I need to do is take negative 6 times 3. And negative 6 times 3, well, they have different signs, so it's going to be a negative answer. And 6 times 3 is 18. Now, if you would like, and I encourage you to do this, double check by sticking in whatever you found out for your x and plugging it back into the initial equation. Okay, so if I were to take negative 18, that's what I found out x is, and divided by 3, would I get negative 6? Negative 18 divided by 3, yes, you would get negative 6. So that's how you can always double check your answer. All right, let's look at the next one. Now I have 18 equals negative 4y. And it's a little bit different because now my variable is on the right-hand side of my equation. And you might be saying, well, what does that matter? Does that make a difference? And the answer is no, not really. Okay, so we can just solve this the same way. I'm going to think about my equation as a left-hand side and a right-hand side. And I'm going to ask myself, what is being done to my variable? Well, my variable is y, and I see negative 4 is written right next to y. So remember, that implies multiplication. When anything is smushed next to a variable like that, that implies multiplication. So negative 4 times y. How do I undo that? How do I get my variable all alone? How do I get that isolated? Well, the opposite of multiplying by negative 4 would be dividing by negative 4. And why? Why is that? Well, negative 4 divided by negative 4, anything divided by itself is 1. So I get 1y, which is the same as just y. Okay. If I divide by negative 4 on the right-hand side of my equation, I need to divide by negative 4 on the left-hand side as well. Okay. Now I know it's going to be a negative, and how many times does 4 go into 18? 4 whole times, which would be 16. I'd have 2 fourths left over to get to 18, which simplifies to a half. So negative 4.5 or negative 4.5 is equal to y. Okay, again, you can check this. Go to your initial equation and put in negative 4.5 for y. Negative 4 times negative 4.5, a negative times negative would be a positive, and 4 times 4.5 would give you 18. So yes, it works. Okay, so always check your answer to be sure. All right, please pause the video now so that you can try 1, 2, and 3 on your own. Alrighty, for number 1, x is being divided by 5. So to undo that, I would multiply by 5 on both sides of my equation. Multiplying by 5 and dividing by 5 are inverse operations. I will get 1x equals, now all I need to do is negative 2 times 5, which would give me negative 10. Okay. Double check that. Is negative 10 divided by 5 negative 2? Yes, it is. Okay. This next one looks a little bit confusing. It says negative a equals negative 24. Well, again, remember, we can assume there's 1 here. So this is the same as negative 1a equals negative 24. And we don't want to know what negative a is. We want to know what positive a is. So how do I undo multiplying by negative 1? Well, you would just divide by negative 1. And whatever you do on the left, you have to do on the right. So negative 1 divided by negative 1 would be positive 1, or positive 1a, equals negative 24 divided by negative 1. They have the same sign. It's going to be positive 24. And look at the comparison. If I know negative a is negative 24, positive a should be positive 24. Okay. And then lastly, number 3. I've got 3 equals negative 1.5n. So negative 1.5 times what number will give me 3? Again, you can also think of it as split it down the equal sign. n is being multiplied by negative 1.5. To undo that, I would divide by negative 1.5. And I need to do that on both sides of my equation. Okay? Negative 1.5 divided by negative 1.5. Anything divided by itself is 1n. And then how many times does 1.5 go into 3? Well, that would be 2. And then a positive divided by a negative. They have different signs, so it would be negative 2. Okay, remember that's the same thing as this, n equals negative 2. It doesn't matter that my number is written first and my variable is written second. That's okay. Either works. Right, in example 2, we solve equations using reciprocals. Remember, reciprocal is when the denominator and the numerator are flipped. So an example of that would be like 3/5. The reciprocal of 3/5 would be 5/3. Remember when you move your denominator and numerator and they switch places. Okay. So for letter A here, it says solve negative 4/5 times x equals negative 8. So I'm asking myself in this problem, what is being done to my variable? Well, this fraction is actually smushed right next to my variable. So that means it's being multiplied by negative 4/5. To undo that, we would divide by negative 4/5 on both sides of my equation. Anything divided by itself is 1. Negative 4/5 divided by negative 4/5 will just be 1x equals, I have a negative divided by a negative, so I know I'm going to end up with a positive answer. And then remember how we divide fractions. 8 over 1 divided by 4 over 5. You could include the negatives, but I know it's going to be a positive answer, so I'm just going to forget the signs for now. And if you don't remember, from last year, we used this acronym KFF, which stands for keep, flip, flop. Keep your first fraction the same, flip your division to multiplication, and flop the second fraction to its reciprocal. So 5/4, right? Making my numerator the denominator and the denominator my numerator. Now I can go ahead and either simplify first, so I could simplify 8 and 4 here, or I could multiply across. Either will work. So 8 times 5 is 40 over 4. 1 times 4 is 4. And 40 divided by 4, 4 goes into 40 10 times. So x is equal to 10. Again, let's double check this. Negative 4/5 times, whoops, I lost my 1 there. 10. Negative 4/5 times 10. What is that? 4/5 times 10. Well, 4 times 10, negative 4 times 10 is negative 40, over 5 times 1 is 5. And what's negative 40 divided by 5? Well, that would be negative 8. So we're correct. Okay. Same type of situation for letter B, except now my variable's on the right-hand side. Again, that's no different. Essentially, that's the book just trying to confuse you. So this says 3/2 times z. So to undo multiplying by 3/2, I would divide by 3/2 on both sides. 3/2 divided by 3/2 is 1. 1z equals, okay, those cancel. Now I have negative 6, which is the same as negative 6 over 1, divided by 3/2. Again, I'm dividing fractions here, so I'm going to do my, remember my acronym of keep, flip, flop. Keep my first fraction the same, flip my division to multiplication, and flop the second fraction to its reciprocal. Okay. Negative 6 times 2 is negative 12 over 1 times 3 is 3. And negative 12 divided by 3, different signs, gives me a negative answer when I'm multiplying or dividing. Negative 4 for my answer. Okay. Go ahead and do those do 4, 5, and 6 here on your own. Please pause the video. Do it the same way we did the last two examples. Okay, for time's sake here, I'm just going to give you the answers, but let me know if you need more help on them. For number 4, you should get b equals -3 and 1/8. Number 5, you should get h equals -24. And number 6, you should come up with x equals -21. Again, please ask if you need help on any of those. For example 3 here, we've got a word problem. It says the temperature at midnight is shown at the left. So at midnight, it is 56 degrees. The temperature decreases 4.5 degrees Fahrenheit each hour. When will the temperature be 32? Okay, so this temperature is 56. It's slowly decreasing 4.5 degrees each hour. Okay, so as 1 hour goes by, when it goes from midnight, so 12 a.m. to 1 a.m., 1 hour has gone by, so it's decreased 4.5 degrees. So if it started at 56 and we subtracted 4.5, what would we be at? Well, that would be 51.5 degrees, right? After 1 hour. So at 1 a.m., it'd be 51.5 degrees. Okay, you could keep going and using this pattern, but that would kind of take you a little while to figure out, and it might not be on the exact hour. So instead, what I would like to do is I'd like to use this information to write an equation, write and solve an equation to find the time of what time will it be when the temperature reaches 32 degrees Fahrenheit or freezing. Okay, so to determine when the temperature will reach 32, let's see, find how long it will take the temperature to decrease. Well, if I have 56 as my starting and I know that it ends at 32, how much did I decrease in temperature? Well, if I take 56 degrees, which is what I start out at, and I subtract where I finish at 32, I'll find my change. So that would be 24 degrees represents the change in temperature. Okay, so therefore, I can kind of think of it this way. The temperature change should equal my hourly change times however long that was. Right? I know that it changes 4.5 degrees Fahrenheit for each hour. I don't know that time yet. That's what I'm kind of looking for. That'll give me my temperature change. Okay, well, let's see what I'm given in this problem. I know my temperature change. If I start at 56 and I end at 32, I know that change is 24 degrees. And I'm actually going to think of it as a negative number because I'm decreasing in temperature. Same with my hourly change. It's decreasing 4.5 degrees. So decreasing, I'm going to represent by -4.5 degrees. And I'm trying to find the time. I don't know that, so I'm just going to call that T. Okay. So -4.5 degrees each hour times the time should give me that temperature change. Okay. So let's see if we can solve this. How would I undo multiplying by 4.5? Well, I would divide by -4.5 on each side. 4.5 divided by 4.5 is 1t equals, how many times does 4.5 go into 24? Well, you can solve that multiple different ways, right? You could do it like this, 24 divided by 4.5, and then you need to make this divisor into a whole number and move your decimal one place. You could do it that way. You could think of it as 24 over 1 divided by 4.5, which 4.5 is, let's see, 9 halves. And then you could do keep flip flop. You could do this a number of different ways, but when you solve, you should arrive at 5.33, and that repeats. Remember that 0.33 repeating is the same thing as 1/3. Okay? 0.66 repeating is the same thing as 2/3. Okay? Those are a good kind of just quick mental math, decimals and fractions to know. So the time is 5 o'clock, and then we're looking for what does 1/3 represent in terms of time. What does 1/3 of an hour? Well, 1/3 times 60, same thing as 60 divided by 3 would give me 20. 1/3 of an hour would be 20 minutes, right? 20, 40, 60. So 5 o'clock, 5:20, and that would be a.m. Okay. So that represents the time. It would be 5:20 in the morning, so bright and early in the morning, when the temperature is 32 degrees Fahrenheit. All right. Kind of a tricky one, but sometimes those word problems can be. We're going to end with the more practice. Please pause the video again now. Try these out to see how it's coming along for you. And in a minute, I'll give you the answers. All right, for number 7, you should arrive at 4. D equals 4. 6 times 4 is 24. For number 8, t equals what number divided by 3 is -4? That'd be -12. Number 9, you might need to use the reciprocal again. You should get p is equal to 15. For number 10, it says, explain why you can use multiplication to solve equations involving division. Well, that's because multiplication is the inverse of division, and we can undo whatever is being done to our variable to solve for that variable. Okay. Number 11 says the equations -2/3 m equals 4 and -4m equals 24 equivalent, and explain. You should get yes, they are equivalent, because when you solve them, m is equal to -6 in both of these equations. And then lastly, describe the inverse operation that will undo the given. So what's the opposite or the inverse of subtracting 12? Well, that would be adding 12. What's the opposite of multiplying by -1/8? That would be dividing by -1/8. And what's the opposite of adding 6? That would be subtracting -6. The opposite of adding -6 would be subtracting -6. So basically, you're just looking for the opposite or the inverse of these operations. All right, that wraps up 4.2 and solving equations using multiplication or division. Again, try to remember this question and keep asking yourself that question: what is being done to my variable and how do I undo it? And then keeping in mind that an equation is like a balance beam or a scale. And whatever you do to one side, you need to do to the other. All right. Thanks for checking this out. I'll see you guys next time.